The next question before us is question number 41. In this question, he is giving us the information about three different complex numbers Z1, Z2 and Z3 such that mod Z1 is 2, mod Z2 is 3, mod Z3 is 4 and modulus of 2Z1 plus 3Z2 plus 4Z3 is 4. Then the absolute value of 8Z2 Z3 plus 27Z3 Z1 plus 64Z3 Z2 is equal to. He is asking about the absolute value, that is modulus of 8Z2 Z3 plus 27Z3 Z1 plus 64 Z1 Z3. Let us now try to calculate. It is of course one of the most simplest questions. It has given us four options. The first option is 24, second option is 48, option C is 72 and option D, that is the fourth option, is 96. Okay, he has given us mod Z1 is equal to 2, mod Z2 is equal to 3, mod Z3 is equal to 4. Besides these, he has given another lengthy information also, that is mod 2Z1 plus 3Z2 plus 4Z3 is 4 again, 4. Okay, what do you require? What do you want to calculate? The value of, absolute value of, that is modulus of 8 Z2 Z3, Z2 Z3, modulus of 8 Z2 Z3 plus 27 Z3 Z1 plus 64 Z1 Z2. Now, this can be written as Z1, Z2, Z3 into 8 by Z1 plus 27 by Z2 plus 64 by Z3, isn't it? And if you can split this modulus symbol, this is equal to mod Z1 into mod Z2 into mod Z3 into mod 8 Z1 bar by Z1 Z1 bar plus 27 Z2 bar by Z2 Z2 bar plus 64 Z3 bar by Z3 Z3 bar. You can easily recognize what is the step I could have followed here. Here you are having 1 by Z1. I have multiplied just this fraction only on both numerator and denominator with the conjugate of Z1, that is Z1 bar. Similarly this with Z2 bar, that is the complex conjugate of Z2, and here the complex conjugate of Z3, that is Z3 bar, is 64 Z3 bar by Z3 Z3 bar. Now what is Z1 Z1 bar? From the basic and elementary concepts of complex numbers, Z1 Z1 bar is nothing but mod Z1 square. What is mod Z1 square? It is 4, isn't it? So this is equal to, what is mod Z1? 2. What is mod Z2? 3. What is mod Z3? 4 into 4 into mod 8 Z1 bar by what is Z1 Z1 bar? Mod Z1 square. What is mod Z1 square? It is 4 or 2 square plus 27 Z2 bar by what is Z2 Z2 bar? Mod Z2 square. It's nothing but 3 square plus 64 Z3 bar by what is Z3 Z3 bar? Mod Z3 whole square. What is mod Z3? 4. So it is 4 square. Let us now simplify this still. 2 into 3 into 4 is 6 4s are 24. 24 into what is 2 square? 4. 8 by 4 is 2. So this is 2 Z1 bar. Again 27 by 9, 3Z2 bar. 64 by 16. 4 square is 16. 64 by 16 is 4. It is 4Z3 bar. This is equal to 24 into modulus of 2Z1 plus 3Z2 plus 4Z3 bar. Yes. If A, B, C are real numbers, then AZ1 plus AZ2 plus AZ3 whole bar is nothing but AZ1 bar plus BZ2 bar plus CZ3 bar. Conjugate of sum of complex numbers is nothing but the sum of their conjugates from the earlier properties of complex numbers. Therefore, we will be able to write this one like this. Again, another important concept regarding modulus of complex numbers is mod Z is equal to mod Z bar. That is, a complex number and its conjugate will have the same absolute value. Basing on that, this can be taken as 24 into modulus of 2Z1 plus 3Z2 plus 4Z3. Luckily, we are given that value. What is the value of mod 2Z1 plus 3Z2 plus 4Z3? It has been given as 4. Hence, the right answer and the required answer is, of course, is 96. Is it available? Yes, of course, it is in the option D. The fourth option is the right option. That is 96 is the right answer. So, here, the main and crucial idea that one must get to get it simplified is you get Z1, Z2, Z3 out. Of course, 8 by Z1, by Z2, by Z3 will be looked here, will be observed here. And of course, by multiplying with Z1 bar here, Z2 bar here, Z3 bar here, you will be able to have this. So this is the necessary idea that one must get to get the answer immediately. Of course, the answer is 96. It is available in the fourth option. That's it. That is the answer for the question is fourth option. That is option D. That is 96. The next question before us is question number 42. Let us look at the question. If the ratio 1 minus Z by 1 plus Z is purely imaginary, then what should happen? Option A, 0 less than mod Z less than 1. Option B, mod Z is equal to 1. Option C, mod Z must be greater than 1. Option D, bounds for mod Z cannot be decided. What is the right option? What is the right way to think of? Let us check. Yes, what has been given? Basically, Z is a complex number. 1 minus Z by 1 plus Z is purely imaginary. Well, at this juncture, let us now recollect one of the most beautiful and important concepts of complex numbers, that is, if Z is purely imaginary, then Z plus Z bar is equal to 0. Isn't it? And it is very easy to verify it also. Suppose Z is A plus IB. Automatically Z bar is A minus IB. A minus IB. Then what is Z plus Z bar? It is 2A. If Z plus Z bar is pure, if Z is purely imaginary, then A must be 0, isn't it? If at all it is given that Z is purely imaginary, it shouldn't contain any real part. That is A, the real part of Z must be 0. Hence this is 0. Therefore, we can say that Z is purely imaginary implies Z plus Z bar is equal to 0. It is an easy matter to recollect that. For every complex number this happens, and in the present question he is giving us about 1 minus Z by 1 plus Z is purely imaginary. In what way we can make use of this concept in this question? It's very simple. 1 minus Z by 1 plus Z plus conjugate of that should become 0. Let us now make use of that. Well, what is the data here? 1 minus Z by 1 plus Z is purely imaginary. What should happen? 1 minus z by 1 plus z plus 1 minus z by 1 plus z bar must be 0. As it is purely imaginary, this sum of this number and its conjugate should be 0. Okay, that is 1 minus z by 1 plus z plus 1 minus z bar by 1 plus z bar must be 0, because conjugate of a quotient is quotient of the conjugate, that is 1 minus z whole bar by 1 plus z whole bar. 1 minus z whole bar is nothing but 1 bar minus z bar. 1 bar is 1 being a real number. Hence it is 1 minus z bar by 1 plus z bar is equal to 0. Let us now consider the LCM. What is the LCM here? What is the LCM here? 1 plus z 1 plus z bar. Here 1 minus z into 1 plus z bar, 1 plus z 1 minus z bar is equal to 0. Let us think of the numerator first. Multiply 1 into 1, 1. 1 into z bar, minus z into 1, minus z, minus z bar. Here 1 into 1, 1, minus z bar, plus z, minus z bar, by 1 plus z into 1 plus z bar is equal to 0, isn't it? Now you observe plus z and minus z bar and plus z bar will go away. One is z bar, mod z square. What is z bar? Mod z square. 1 plus 1, 2. All together the numerator becomes 2 minus 2 into mod z square by 1 plus z into 1 plus z bar is equal to 0. Thereby you will be going to get 2 is equal to 2 into mod z square, or mod z whole square is 1, leaving you mod z is equal to 1. Is it available? Of course it is available in the option B. The second option is the right option. Mod z is equal to 1. The only concept which helped us here in solving the question and which we could make use of is if a particular complex number is purely imaginary, then the sum of that complex number and its conjugate should vanish, that is 0. We have made use of that concept to have the answer, that is mod z is equal to 1. Option B is the right option. Now it is our turn to look towards the next question, that is question number 43. In this question, if P and Q are represented by the complex numbers Z1 and Z2 such that modulus of 1 by Z1 plus 1 by Z2 is equal to modulus of 1 by Z1 minus 1 by Z2, then the circumcenter of the triangle OPQ, where O is the origin, is. Well, he has given us two complex numbers P and Q. Of course, given by the complex number Z1 and Z2, they are the points in the organ diagram, so that our triangle OPQ is formed. We are interested to know the circumcenter of the triangle, and the options given us are option A, Z1 minus Z2 by 2, option B, Z1 plus Z2 by 2, option C, Z1 plus Z2 by 3, option D, Z1 plus Z2. Let us see. First of all, what is P? Complex number Z1. What is Q? Complex number Z2. What is the data given about them? Modulus of 1 by Z1 plus 1 by Z2 is equal to 1 by Z2 minus 1 by Z1. Isn't it? Implies I have just taken the LCM on both the sides, about the quantities in LHS and RHS also. So that multiplying on both sides with mod Z1 and mod Z2, you will be having modulus of Z1 plus Z2 is equal to modulus of Z1 minus Z2. Mod Z1 plus Z2 is equal to mod Z1 minus Z2. And I would like to put squares on both the sides also. Is it a sin? Does it make any harm? No harm at all. I'm squaring. Moreover, if you think this complex number has some Z, mod Z square, what is that? Z bar, isn't it? So that you can write this as Z1 plus Z2 into Z1 plus Z2 bar. Z1 minus Z2 into Z1 minus Z2 bar. Again, this implies Z1 plus Z2 into Z1 bar plus Z2 bar is equal to Z1 minus Z2 into. It's very simple, of course, to trace this step. We have made use of the concept that the conjugate of a sum of complex numbers is nothing but the sum of the conjugates, and accordingly about the difference also you'll be making use of that, like that. Let us now multiply them, just a blunt multiplication. Let us see what is going to happen. Z1 into Z1 bar, Z1 into Z2 bar, Z2 into Z1 bar, Z2 Z2 bar. What happens on the left or right hand side? Z1 Z1 bar minus Z1 Z2 bar minus Z2 Z1 bar plus Z2 Z2 bar. What is Z1 Z1 bar? Mod Z1 square. Mod Z1 square, mod Z1 square. You can cancel. What is Z2 Z2 bar? Mod Z2 square. Mod Z2 square, mod Z2 square. You can cancel. You see, minus Z1 Z2 bar comes this side. Minus Z2 Z1 bar comes this side. No, it is Z2 Z1 bar only. Yes. If both of them come here, what is going to happen? Implies 2 into Z1 Z2 bar plus Z2 Z1 bar is equal to 0. Is equal to 0. Therefore, what are the consequences? This 2 bloody 2 it goes that side, so that you will be having Z1 Z2 bar plus Z2 Z1 bar is equal to 0. I like to write like this. Z1 Z2 bar plus Z1 Z2 bar whole bar is equal to 0. Any problem? You observe that? Z1 Z2 bar whole bar. What does it mean? Z1 bar into Z2 bar bar, that is Z2. So it is Z2 Z1 bar. Now you imagine Z1 Z2 bar as a whole, one single complex number, say Z. What have you had here? Z plus Z bar is equal to 0. And it does imply that Z is purely imaginary, isn't it? Implies Z1 Z2 bar is purely imaginary. Isn't it? Z1 Z2 bar is purely imaginary. But you see, Z1 Z2 bar is nothing but Z1 Z2 bar into Z2 by Z2. Any problem? What is Z2 Z2 bar? Mod Z2 square. It is Z1 by Z2 into mod Z2 square is purely imaginary. Imaginary, isn't it? Mod Z2 square is of course an absolutely non-negative real number. We can ignore that, so that you can be saying that Z1 by Z2 is purely imaginary. Is purely imaginary. Purely imaginary. Z1 by Z2 is imaginary means argument of Z1 by Z2 is 90. Isn't it? Argument of Z1 by Z2 is 90. Implies argument of Z1 by Z2 is 90. That is pi by 2 rather. Argument of Z1 by Z2 is just nothing but the angle POQ. Am I correct? Angle POQ. That is a valuable step which we could have achieved at the last. Angle POQ is 90. From which step are you able to have Z1 by Z2 is purely imaginary? It does mean that argument of Z1 by Z2 is pi by 2. And by looking at this step, angle POQ is 90. It is a right-angled triangle. Of course, right-angled at the origin. At the origin. Whatever it might be, it is a right-angled triangle. Hence, but about the circumcenter, what can you say about the circumcenter of a right-angled triangle? In the case of a right-angled triangle, we all know that the circumcenter is just nothing but the midpoint of the hypotenuse. Here in the triangle OPQ, O is the vertex containing the origin. Hence, what is the hypotenuse? PQ. Therefore, the circumcenter is the midpoint of the hypotenuse, that is midpoint of PQ. We know about P and Q, they are Z1 and Z2. Hence, the midpoint of PQ is just nothing but Z1 plus Z2 by 2. Is it available? Surely, of course, in the option B. Yes. It's a beautiful question in which 2 or 3 different concepts are under use. One of the most important concepts is the triangle OPQ is a right-angled triangle. Right-angled at O. Hence, hypotenuse is PQ. The circumcenter is the midpoint of the hypotenuse. Therefore, midpoint of PQ is the correct answer. And the right option, that is option B, is the right answer. That is the question. That is the answer. Now, this is the time for us to go through the next question. That is question number 44. In this question, he is giving about the nature of a particular complex number, say alpha. Alpha is a non-real root of x power 7 is equal to 1. We know that the roots of x power 7 is equal to 1 are called seventh roots of unity. Out of them, 1 is also a root. It is a real root. And he is giving about alpha as a non-real root. So we are sure that alpha is not equal to 1 because 1 is real. Well, alpha is a non-real root of x power 7 is equal to 1. Then 1 plus 3 alpha plus 5 alpha square plus 7 alpha cube, etc., etc. 13 alpha plus 6 is equal to. He is asking about the value of that 1 plus 3 alpha plus 5 alpha square plus 7 alpha cube and so on. Yes. How can we trace that? Of course, the options given here are, first option is 0, second option is 14 by 1 minus alpha, third option, that is option C, is 14 by alpha minus 1, and the fourth option is none. Let us examine it. Yes. What is the given equation first of all? X power 7 is equal to 1. He is saying that alpha is a non-real root, implies alpha is not equal to 1 and alpha power 7 is equal to 1. Alpha is not equal to 1 and alpha power 7 is equal to 1. Yes, of course, as alpha is the root of the equation, alpha power 7 must be 1. Moreover, what is required actually? 1 plus 3 alpha plus 5 alpha square plus 7 alpha cube plus 9 alpha power 4 plus and so on 13 alpha power 6 he is asking us. Let me name this big sum. Say sum capital S. We are to know the value of this sum, the big sum, 1 plus 3 alpha plus 5 alpha squared plus 7 alpha cube and so on. Well, to have this, let us use the techniques those can be used in the sum of series. In obtaining the sum of some different series, we could have designed certain methods. Let us use that methodology. Well, S is equal to that much. You just calculate S into alpha. What happens? Multiply both the sides with alpha. 1 into alpha, alpha plus 3 alpha square plus 5 alpha cube plus 7 alpha power 4 and so on, etc. 13 alpha power 7. Am I correct? Good. Let me now just subtract. What is S minus S alpha? S into 1 minus alpha. S into 1 minus alpha. 1, no more constant is here, 1. 3 alpha minus alpha, 5 alpha square minus 3 alpha square, 2 alpha square. 7 alpha cube minus 5 alpha cube, 2 alpha cube. And so on. 13 alpha power 6 minus 11 alpha power 6. What is the term which lies just before this? It is 13 alpha power 7. What is the next succeeding term here? 11 alpha power 6. 13 alpha power 6 minus 11 alpha power 6 is 2 alpha power 6 minus 13 alpha power 7, isn't it? Is equal to 1 plus, let me get 2 as a common factor, alpha plus alpha square plus alpha cube and so on, alpha power 6 minus 13. Well, where does that alpha power 7 go? Alpha power 7 is 1. I could have made use of that. Yes, of course. In the place of alpha power 7, we can use 1. Therefore, it is minus 13. Well done. 1 minus 13. How much? Minus 12 is equal to minus 12 plus 2 into. You can observe this. This is just nothing but a geometric progression containing how many terms? 6 terms. This is the sum of a GP containing 6 terms. What is the answer? A into 1 minus by 1 minus R. Isn't it? I have made use of the formula to find the sum to n terms of a GP. A is the first term and R is the common ratio. What is the first term here? Alpha. What is the common ratio? Alpha. So A into 1 minus R power n by 1 minus R. So this is minus 12 plus 2 into alpha into 1, alpha. Alpha into alpha power 6, alpha into alpha power 6. Alpha into alpha power 6 is alpha power 7. But alpha power 7 is 1. Hence we can write this as alpha minus 1 by 1 minus alpha. Okay. Alpha minus 1 by 1 minus alpha is minus 1. Hence this is minus 12 plus 2 into minus 1 is nothing but minus 14. Well said. What is this value? Is it the required sum? No. S into 1 minus alpha is that. Therefore, S into 1 minus alpha is equal to minus 14. From that, we will be able to have 14 by alpha minus 1. What is this? 14 by alpha minus 1. What is the correct answer? Option C. Yes. It's a very, very simple manipulation of obtaining the sum of a series. Of course, it is a finite series. So, this is the crucial idea that one must possess to have the answer. Hence, the answer is 14 by alpha minus 1. Not only that, by looking at the options also, you'll be able to get the idea. In two options, 1 minus alpha or alpha minus 1 is available. Then and there itself, you must be able to get the idea, oh, we may have to get the sum s into alpha minus 1 or s into 1 minus alpha. How can you get that? S is there. You must be able to have alpha into s. By subtracting one from the another, you will be getting s into 1 minus alpha. Yes. By looking at the options, you will be getting the idea. Hence, the right answer is 14 by alpha minus 1 is the correct answer. Is option C is the right answer. We shall now see the next question which is before us. That is question number 45. If a complex number z lies in the interior or on the boundary of a circle of radius 3 units and center at minus 40, then the greatest and the least value of mod z plus 1 are respectively, he is asking us. And he has given the position of the complex number z, of course, very clearly. Either it lies in the interior or it lies on the boundary of a circle with center minus 40 and radius 3. The full information about the circle has been given. Yes, the full details about the circle are given. What type of the circle it is? Center minus 40 and with radius 3 units. Okay, what are the options given? 5, 0. Second option 6, 1. Third option 6, 0. And the fourth option 5, 1. Okay, let us see. First of all, what is the circle given? What is the center of the circle? Imagine that the complex number is here, z. This is, what is this distance? Radius. If the complex number z lies on the boundary of the circle, what should happen? This distance must be, 3 units. That is mod z plus 4 is equal to 3. If the complex number z lies on the boundary of the circle, there might be another case also. What is that case? The same circle, center is minus 40. Imagine that the complex number z lies in the interior. Then what should happen? This distance must be less than the radius, isn't it? That is, mod z plus 4 is less than the radius, that is 3. We are given about z, either it lies in the interior or it lies on the boundary. Out of these two cases, any case may happen. So that by clubbing these two, what can you say? Mod z plus 4 is less than or equal to 3. Mod z plus 4 is less than or equal to 3. Okay. That is, so far we have understood or we have analyzed the situation given about z. Well, let us now think of the question. What is required? We are required to have the maximum array and the minimum or the greatest and the least values of mod z plus 1. Let us think of mod z plus 1. This can be written as mod z plus 4 minus 3. Isn't it? 4 minus 3 is 1. This is less than or equal to mod z plus 4 plus mod 3. I think you can agree with this. Why? Because If Z1 and Z2 are two complex numbers, then mod Z1 plus Z2 is less than or equal to mod Z1 plus mod Z2. Here of course this is Z1 and this is Z2. You can think of so that mod Z1 plus mod Z2. Hence, what is mod Z plus 4 is less than or equal to 3. What is mod 3? 3. 3 plus 3 is 6. What are you able to observe here? Mod Z plus 1 is less than or equal to 6. We should feel happy. What is the maximum value of mod Z plus 1? 6. Isn't it? Less than or equal to 6. What does it mean? It can never exceed 6. It can at most be 6. It means that the maximum value, that is the greatest value, is 6. Then it is available in two options. Option B, it is 6. Option C, it is 6 about the greatest value. Well, what about the least value? Unless you decide the least value of mod Z plus 1, you cannot decide which option is the right option. Therefore, now it is on our shoulders to decide the least value or the minimum value of mod Z plus 1. Well, one thing you must notice, for any complex number, mod Z is always non-negative, isn't it? That is, mod Z is always greater than or equal to 0. Similarly, mod Z plus 1 is always greater than or equal to 0. So, one of the minimum possible values is 0. Let us see what happens. Is it true or not? If the least value of mod Z plus 1 is 0, then mod Z plus 1 can take the value 0. What happens if mod Z plus 1 is equal to 0? Z plus 1 is equal to 0. Z is equal to minus 1. Is it possible? Does this information suit about the data? Satisfy the data? Let us see. But if at all Z is minus 1 plus 4 is 3. So mod Z plus 4 is equal to 3. There is no problem at all. There is every possibility for Z to happen like that. Therefore, Z is equal to minus 1 also satisfies the data. Hence, we can believe and we declare that the least value of Z plus 1 is 0. Mod Z plus 1 is 0. Hence, we could have decided, we have taken the decision, least value of mod Z plus 1 is 0 and the greatest value of mod Z plus 1 is 6. Therefore, 6 and 0, they are available in option C. So, the suitable option is option C. And the right answer is of course 6 and 0. Right. That is the answer. Let us now see the next question. Question number 46. The least positive integral value of n for which 1 plus I by 1 minus I whole to the power of n is equal to 2 by pi into sine inverse of 1 plus x square by 2x, where x is supposed to be positive and I is the imaginary square root of minus 1 is asking about. And a lengthier equation has been given for us. Let us simplify that. And the options given for the answers are: first option is 2, option B is 4, option C is 8, option D is 12. Let us see about the question. What is the equation given? One plus I by 1 minus I whole to the power of n is equal to two by pi into sine inverse of 1 plus x square by 2x. 1 plus x square by 2x. Of course, he has given us x is positive and I is of course square root of minus 1, which everybody knows about it. In the beginning of complex numbers itself, it is the brand ambassador of a set of complex numbers, that is I, of course. Well, we are to decide the minimum possible value of n so that this equation might be satisfied. See, one of the most important things here to look at is sine inverse function. We know that range of sine function is closed interval -1 to 1 implies domain of sine inverse function is closed interval -1 to 1. Therefore, for this to be defined, what should happen? -1 less than or equal to 1 plus x square by 2x less than or equal to 1. Right? Unless or otherwise, sine inverse of something cannot be defined at all because it is nothing but the domain of the sine inverse function. Isn't it? Well, you look at this step. From this step, what can you say directly? 1 plus x square by 2x is less than or equal to 1. That is 1 plus x square by 2 mod x less than or equal to 1. I have distributed this absolute value symbol, that is modulus symbol, to both numerator and denominator. And moreover, you look at the numerator here, 1, a positive number, x square, a non-negative number. So 1 plus x square, surely positive number. Surely positive number. Hence, 1 plus x square, mod of 1 plus x square is just nothing but 1 plus x square. So 1 plus x square by 2 mod x minus 1 less than or equal to 0. I have brought that 1 this side, that's all. Now you take the LCM. One plus x square minus 2 mod x by 2 minus 2 mod x by 2 mod x is less than or equal to 0. Therefore, you can write the numerator as mod x minus 1 whole square isn't it? Mod x minus 1 whole square, you expand it, mod x square, that is x square, plus 1, okay, minus 2 mod x, present. Well, in this fraction, the denominator is absolutely positive. Why? Because x is greater than 0, he has given. Mod x is surely greater than 0. Therefore, what happens? Mod x minus 1 whole square less than or equal to 0. Well, look at that. Mod x, absolutely real number. Minus 1, real number. Mod x minus 1 whole square, non-negative real number. And he is saying that it is less than or equal to 0. Here, less than 0 is not possible. The square of a real number cannot be less than 0. It's not possible in the set of real numbers. Hence, what should happen? Mod x minus 1 whole square should be 0 only. Thereby, you'll be getting mod x is equal to 1. Mod x is equal to 1 means x is plus or minus 1. Mod x is 1 means x is plus or minus 1. But we are assured that x is positive. So, what should happen? X is equal to 1. Now, you get that x is equal to 1 substituted in the given equation. What are you going to have? What are you going to have? Let us observe that thing here. One plus I by 1 minus I whole to the power of n is equal to 2 by pi into, I am getting x as 1. 1 square is 1. 1 plus 1, 2. 2 by 2 ones are 2. 2 by 2 is 1. Sine inverse 1. What is sine inverse 1? What is sine inverse 1? Pi by 2. 2 by pi into pi by 2, what is that? 1. 1 plus I by 1 minus I whole to the power of n is 1. Here, it is an important thing to observe that 1 plus I by 1 minus I is just nothing but I. How? How can you believe that it is I? It's very simple. You multiply both numerator and denominator with 1 plus I. What happens? 1 plus I whole square by 1 minus I into 1 plus I. 1 square plus 1 whole to the power of n is equal to 1. What is 1 plus I whole square? Let me make use of the space available here. What is 1 plus I whole square? 1 plus I square plus 2I by 2 whole to the power of n is equal to 1. What is I square? Minus 1. 1 and minus 1 go away. 2I by 2 is nothing but I power n is equal to 1. You now recall the consecutive values of n. I power 0 is 1. But n is a natural number, positive integer. So, after 0, I power 1 is I. I square is minus 1. I cube is minus I. I power 4 is 1 we have got. Yes. For the first time, to get 1, n must be 4. So the least value of n such that I power n is 1 is nothing but 4. Therefore, the least value of is 4. 1, 2, 3, I power 1, I power 2, I power 3, they cannot be 1, and I power 4 is only 1. Therefore, the least value of n for which I power n is 1 is 4. What is the right option? Option B is the right option. Right answer is 4. We now look at the next question, that is question number 47. In this question, alpha is a complex number such that mod alpha is equal to 1. Then the value of a so that az square plus z plus 1 is equal to 0 has only purely imaginary roots is. Let me read the question once again. It is not alpha, it is a. A is a complex number such that mod a is equal to 1. As mod a is equal to 1, you can take a as cos theta plus I sin theta. Okay, we shall see later. Then the value of a is such that az square plus z plus 1 is equal to 0 has only purely imaginary roots is. It has given as usual 4 options. In the first option, there is option A is equal to cos theta plus sin theta, where theta is equal to cos inverse of root 5 minus 1 by 2. In all the options, A is given as cos theta plus I sin theta, and the options vary from the value of theta only. In the first option, that is option A, theta is cos inverse root 5 minus 1 by 2. In the second option, cos inverse root 5 minus 1 by 2. In the third option, root 5 minus 1 by 4. And the fourth option, cos inverse minus root 5 minus 1 by 4. Yes. In the option B, it has been given sin theta plus I cos theta. Option D, also sin theta plus I cos theta. Whatever it might be, we'll be exploring the answer first of all, isn't it? Well, basically, what is A? What is A? It's a complex number with unit modulus. That is a beautiful and valuable information has been given. Therefore, A must be either cos theta plus sin theta or sin theta plus I cos theta. Whatever might be the shape, it is mod A is 1. Okay, right. What is the main thing he has given is az square plus z plus 1 is equal to 0 has purely imaginary roots. Let me call this 1. Implies az square plus z plus 1 is equal to, I am considering the conjugates on both the sides, implies a bar z bar square plus z bar plus 1, conjugate of 0 is 0, implies a bar into minus z whole square minus z plus 1 is equal to 0. Do you agree with this step or not? How can we get it? Look at the data. That equation has only purely imaginary roots, is saying. So z is purely imaginary. As in when z is purely imaginary, z plus z bar is 0, isn't it? That I like to write in the brackets. Z plus z bar is 0. As z is purely imaginary, z plus z bar is 0, and in the place of z bar you can write minus z. So that you will be having implies a bar into z square minus z plus 1 is equal to 0. You call this 2. You call this 2. Now you eliminate z from first equation and second equation. From first equation and second equation, what do you have? Come on. Let me try to use the cross multiplication method, rather Cramer's rule, whatever you call. Z square by 1 minus of minus 1, 2, minus z by, come on, 1 minus a bar, no, a minus a bar is equal to 1 by minus a minus a bar, minus a minus a bar. Therefore, from this, z is equal to a minus a bar by a plus a bar, and z square is equal to minus 2 by a plus a bar. Am I correct? Z is equal to a minus a bar by a plus a bar, and z square is minus 2 by a plus a bar. Now let me eliminate z. Z square is z whole square is equal to z square. That is a minus a bar by a plus a bar whole square is equal to minus 2 by a plus a bar. Multiply with a plus a bar on both sides. What do you have? A minus a bar whole square plus 2 into a plus a bar is equal to 0. Is equal to 0. This is the useful step we could have got. Well, let me now try to make use of this step. In the beginning itself, he has said that mod A is equal to 1. Let me write A in mod amplitude form. What do you mean by mod amplitude form? R into cos theta plus I sin theta, where R is the modulus. Here the modulus is 1, so that I can take A as cos theta plus I sin theta. Right. Let A is equal to cos theta plus I sin theta. Automatically A bar is equal to cos theta minus I sin theta. From this we see a minus a bar is 2i sin theta and a plus I bar is 2 cos theta, isn't it? Yes. Now, let me substitute these two in this useful condition to get theta. What is a minus a bar? 2i sin theta whole square plus 2 into A plus A bar is 2 cos theta. 2 into 2 cos theta, isn't it? Is equal to 0. What is 2i sin theta whole square? 4i square sin square theta. That is minus 4 sin square theta plus 4 cos theta is equal to 0. What is sin square theta? 1 minus cos square theta. What is minus sin square theta? Cos square theta minus 1 plus cos theta minus 1 is equal to 0. Of course, 4 is now cancelled. What is minus sin square theta? Cos square theta minus 1 plus cos theta is available here. So that you can be having cos theta is equal to minus b plus or minus root of b square minus 4ac 2a by 2 is nothing but minus 5 minus 1 by 2. That is root 5 minus 1 by 2 cos theta is equal to plus or minus, isn't it? I have taken only plus. Why? Because if you take minus sign here, minus root 5 means root 5 is greater than 2. Minus 1 minus root 5, its absolute by 2, its absolute value will be more than 1. Cos theta cannot be having its absolute value more than 1. Therefore, minus 1 minus root 5 is not possible. That is why I have taken root 5 minus 1 by 2. Therefore, cos theta is equal to root 5 minus 1 by 2 means theta is equal to cos inverse of root 5 minus 1 by 2. It is very clearly available in option A. So, what is the right answer? Option A is the right answer. So, A is equal to cos theta plus I sin theta, where theta is equal to cos inverse of root 5 minus 1 by 2. Yes, that is the answer.